Hi, I'm Tom Cherryholmes, and I'm a longtime Atari 8-bit user. I wanted to put together a demonstration showing what it was like to develop software in the early 1980s, particularly on higher-end Atari 8-bit systems that had hard drives. You didn't see these very often, but there were a few around, mostly in use by successful software designers, and Atari had quite a few of them around sitting on campus. And for this, I actually wanted to show a complete workflow from start to finish of setting up the hard drive, getting it ready for software development, and developing a quick little piece of software with it using the Atari Macro Assembler, the Atari Program Text Editor, and using the Amoeba debugger, which was an internal tool that they had developed for all sorts of nifty debugging and patching needs. I've already covered Amoeba in my previous review, so it won't be exhaustive, but just a passing view of it. So with that, we have here an emulated Atari 800 with 256K of Axlon RAM, which we're not really going to use, so that we can demonstrate the speed of the hard drive. The Atari Macro Assembler, the Atari Program Text Editor, and a 6 megabyte Corvus hard drive. Now, Corvus is actually an interesting company. They were founded in 1979 with the mandate of bringing local area networks and distributed storage to the microcomputer world. And they did this through a series of different products, ranging from their hard drives to multiplexing technology, such as their Corvus multiplexer to allow 8 computers to use one Corvus drive, to an Ethernet clone, which they called OmniNet, which was designed to run on unshielded twisted pair, something that wouldn't show up in the mainstream for at least another 15 years. Interesting, huh? So, with that, the Corvus hard drive is plugged into an Atari interface, and the Atari interface is plugged into joystick ports number 3 and 4, providing a high-speed 8-bit parallel interface. So, with that, let's go ahead and start the process of setting it all up. I've pulled the hard drive out of its casing. I have flipped the format switches off, and so it's ready for actual use because it's been formatted at the factory and ready to go. And all I need to do now is run the sysgen utility, like the manual tells me, so that I can do a high-level format for Atari DOS. So with that, we'll go ahead, attach the appropriate sysgen disk, and with that, reboot the system. I already also have a basic cartridge and ready to go. As per the manual, we run sysgen. And what it's doing here is it's loading firmware so that it can talk to the drive at a low level. This is what's called the BCI. And all we have to do at this point is essentially follow the prompts. We want to initialize our one and only drive. We want to erase everything on it, of course. And we'll go ahead and keep the default options for maximum open files. And we want to have 8 maximum logical devices managed, which is the maximum number you can use anyway. Do you want a tone during I/O? Yeah, we're Atari users, so we do. We want the beep. Now, here's where things get interesting. The way that old hard disk systems worked, there weren't subdirectories. Subdirectories were not available for most microcomputers. Exceptions, of course, being the Apple III at this point. The IBM PC wouldn't have its hard drive solution for another year, and most S100 based operating systems didn't have a concept of subdirectories, although CP/M did have a concept of user areas in MPM. So, what Corvus chose to do instead was to take the hard drive and divide it up into a number of virtual floppy disks. Either, in this case on the Atari, single-sized or double-sized. Now what they mean by this is single-sized is equivalent to one single-sided single-density disk, or 90K of space, and double-sized is equivalent to one single-sided double-density, or 180K worth of space. Now, you might be thinking, okay, well, why don't I just set up 30 double-sided double-sized volumes? Well, problem there is that some pieces of software, in particular the very software we're trying to run, AMAC and MEDIT, don't know how to handle double-density volumes appropriately, even if they're handled virtually by the Corvus hard drive. So they will flake out, they will glitch, they will not work correctly. So the solution is to use 61 single-sided volumes for our purpose. We still get the same amount of space, we just get a lot more drives to split it on. So yes, that is 61 separate disks, and since we're not doing any double-sided disks, 0. And this is a good time for a real system to get up and go grab a cup of coffee, because this can take anywhere between 8 to 10 minutes. Since I'm doing emulation, I can take and go warp speed and speed this up by a factor of about 800%. And we'll do that right now. And as we can see here, we've created the volume table, writing it all out, formatting all these volumes, which means creating all these virtual disks, writing DOS and DUP onto the first one, boot code, etc. So now with all of this, the drive is actually ready for use. But right now, there's no way to boot the drive. So we have to use the provided Corvus boot disk, or use the utilities disk to create one. In my case, I have one ready to go, so I will simply mount it. Go to Corvus boot. And we will go ahead and reset the machine. Now I'm about to do this. Don't blink. Reset. Now you saw two things happening there. That wasn't a glitch. The first thing that you saw happening there was the message network not ready. And that was referring to the fact that the Corvus didn't detect either a multiplexer or an OmniNet card to connect to. In our case, that doesn't matter because we only have one computer, one drive, whatever. So the second thing that you saw was that FMS loaded so fast that you blinked and BASIC was up. Now we're going to take and drive this point home by going ahead and going into the disk utility package. And you can see right there, blink, and we're done. We're in DOS. So with that, we just loaded about 4.5K worth of code in about a split second. So what did that leave us with? Well, by default, Corvus creates a mount table that mounts the first 7 volumes of the disk and sets aside drive 8 to be the first Atari drive, as we can see here. The first volume contains our disk utility package. Drive volume 2, volume 3, and as you can see, with each volume, it creates a small volume label so you know which volume is which. As this is especially helpful if you're not mounting these volumes consecutively. So, with drive 8, we see our custom Corvus 810 boot diskette. Great. Well, I don't want to have to keep taking this thing out, putting it back in, taking it out, putting it back in, so that we can load software onto this thing. So we're going to make one slight change to the mount list. I have 2 drives set aside for our task here. Drive 1 is going to be our Corvus boot disk, because it has to be. And drive 2 we're going to use to load the software onto the hard drive. So for that, all we have to do is load the utilities disk into drive 1 for now. And I should have done a directory there, but there were a number of useful utilities there that can be used for various purposes, such as backing things up, doing diagnostics, and the like. But the utility that we're interested in right here is mount. And see what I did right there? I forgot. Drive 1 is now a Corvus drive, so now we need to deal with it as drive 8. Now, did I actually mount the right disk? Let's see. I don't think I did. Let's find out. And you can see it's loading DUP off of the hard drive, so I could do this just fine. Oh no, I loaded my sysgen tools on accident again. Load the right disk. So yeah, as we can see, there's a handful of utilities on here that are interesting. The diagnostics of diag. Mirror is the backup and restore tool. Now the interesting thing about Mirror is that most Corvus drives have what's called a mirror board inside of them. And that allows you to connect a standard VHS VCR and use it to back up the entirety of your disk in about 20 minutes. It's quite nice, actually. And the utility that we're interested in, of course, is the mount utility here. So we'll go ahead and bounce to basic and load mount. And again, we have to load BCI because we need to talk to the drive at a low level. And we load our volume table. And as we can see, the first 7 volumes loaded from drive 1 to 7, and drive 8 mapped to drive 1. Well, we need to change this. We hit the question mark to look at our menu options, and we have mount a volume, unmount a volume, install a new default mount table, load a saved mount table, and save the current mount table. In this case, we have to unmount our particular drive before we mount it to a new place. So, unmount drive 8. And we mount a new section to drive 8 again. And we're going to map it to an Atari drive, but we're going to map it to drive 2. And now all we have to do is install this as the default mount table. And it will tell us that, yeah, this is replacing the one that's already there. We want this. Yes. So now we've done this. We exit, and we say, yes, we want to use the current mount table right now. Done. So with that, we now have everything we need to actually start doing some serious work. Now, I'm going to go ahead and detach my cartridge. And you'll notice what happened here. I still have my utilities disk in here, so we don't have access to our Corvus drive. It's just not there. The best way to fix this, of course, is to put our disk back in place. And keep it there. And as we can see, there's our Corvus operating system ready to go. Now, we'll go ahead and place the utilities disk into the second drive now. And if we look at drive 8, we have our utilities disk. Now, I know out of all these utilities, the one that I want to use on a day-to-day basis is mount. So we'll take and copy it over. And we need to copy over the BCI firmware, which it needs as well. There we go. So now the next thing is to copy our macro assembler in place. Again, same thing. Load our macro assembler into drive 2. Being careful to select drive 2. Now I have a special version of Atari Macro Assembler 1.0C, which I got from Atari Wiki, which is unprotected, so it can run on hard drives like this, and it runs quite well. Unfortunately, it has a whole bunch of other crap on it, which will simply just take and peel away after I've copied it. And you'll see here, I'm not pressing warp speed or anything. This is copying to the disk, and it's hauling butt. And it really is about this fast on a real Corvus system as well. It's quite remarkable. This was a very desirable peripheral to have back in the day. Now, we will get an error 162 here while trying to move code bust over, but that's fine. We don't need it. We're going to delete it anyway. So with that, we go ahead and start cleaning up. And again, I don't want the RAM disk, it's useless. And we're going to rename the systext to the proper file name. So we're left with our mount utility, which I'll go ahead and rename to mount basic. And we have MEDIT, AMAC, our system text, and the editor to change MEDIT preferences, which I'll show later. So, with this in place, we almost have everything we need. There's one more thing I want to take and copy over, and that's Amoeba. Now, the scary looking VTOC notwithstanding, the load file there for Amoeba is standard and it can be copied without incident. Now I'm going to rename this one as well. And what do we have right there? All of our tools ready to go for basic software development as we need them, with enough space to deal with a growing sys.txt file and any preferences files for MEDIT that we want to take and copy over to our work disks. So, with that, let's go ahead and do one more house cleaning step, and let's lock just about everything. And we want to unlock, and I think we're going to want to unlock, I think, that's good. Okay, just so we don't accidentally delete anything off of here that's critical. So there we go. We now have a complete software development pipeline ready to go. And if I hit reset, let's just pretend that we're powering the system on. It's up a few seconds later. Dang, done. And this is especially true if you keep your Corvus hard drive on and spinning all the time like you should. The only delay that you'll ever incur is if you decide to turn on the Corvus drive at the same time as your Atari machine. Then you'll wait approximately 30 seconds to a minute to wait for the drive to spin up. So just keep it spinning. Anyway, so let's go ahead and do a quick little demonstration of some software development here. We've got a blank disk over here in drive 2 ready to go for software work. Great, we'll use it. We'll load our program editor. Boom, ready to go. And we'll make a new file, test ASM. And right now we're using bog standard defaults, which will change in just a minute. So, okay. We'll go ahead and put this at, whatever, 2000, I guess. That's cool. And it's just going to be a quick program that cycles through colors because I can type this thing in my sleep. So, I want to type too fast for this editor. And I'll go ahead and just use I already know the address I want to use there. I won't use any symbols here. And of course, I can use the arrow keys to come back. Delete key to delete various bits and pieces. And I actually prefer to explicitly specify my start addresses in my code. So that's the run address for DOS2. Okay, there we go. DW start, ready to go. And now to take and save this particular file, well, you have to go into command mode, use the option key to do so. Cause the cursor to come down here, and at that point I can type exit. That saves the file and lets it go. Now, a common fallacy that you do with MEDIT is that you use the return key almost reflexively. But for some reason they decided they don't want you to do that, so you use the start key instead. Maybe as some sort of user interface sanity check. And if we look on drive 2, we see our test ASM ready to go. We'll take and dump it to the screen just for funsies. And we'll see it's just a bog standard text file. How do we assemble it? Well, we load AMAC. And we're presented with the Atari Macro Assembler sign-on screen. Now, the reason for the unusual way this program runs is because this program was subcontracted out to another company. In this case, it was a popular software development company called Sorcim, Sorcim, that made program development tools early on in its life and went on to make clones of VisiCalc and other programs for certain software vendors. In this case, Atari contracted them to make an assembler, and they did a damn good job, honestly. It has every major feature that you need, including macros, conditional assembly, and the like, and it works extremely fast and can work with files of arbitrary length limited only to the amount of storage on your disk, which is a good thing, so you can compile large things. So it's a professional assembler. Works really well. Well, at the very least, we need to tell it what we want to assemble. I don't want any list files or cross-reference files or anything, so all I have to do is tell it the name of the file to assemble, and it will simply do so. Now, it beeped at me, and the first thing you're thinking is, oh crap, what's wrong? But nothing actually went wrong here. As you can see, no errors. It found 2 labels and 4AC2 bytes free here. Ready to go. So there's our program, and it gives you the chance to assemble another one. Well, if you're done, you just hit enter, and it goes back to your operating system prompt here. And if we look in drive 2, we see our compiled object, and we can load it. Since I put a run address in there into E2, it'll just load. And there's our flickering seizure-inducing colors. Yay! So there you go. All ready to go. Now, at any given time, if I want to take and make a change, whatever, I can go in, load the editor, and maybe I want to change maybe I want to change a different color register. Can't remember which one this is, but we'll see. Whatever. Again, option, exit. And the interesting thing here is if you type something that starts to look like an unrecognized command, it'll tell you before you finish making your mistake. It's somewhat predictive, and it's quite nice in that respect. So exit, save. And we'll see something else has actually happened here. If I don't explicitly tell MEDIT not to, it will make a backup file of my last edit for me automatically. Good, awesome, sounds good to me. We'll take and run AMAC again and recompile. And as we can see here, bam, just compiling really quickly. Now, I want to take and actually, I'll take and actually make it take a little bit longer by loading in the default system text, by specifying S as a parameter here. Like that. And you can see, even though it's loading this in and including it and assembling it as part of it, it doesn't add that much. It's still tearing through it pretty quickly. There you go. Bam, done. So it's still tearing through quite nicely and making a good job of it. So now we're changing luminances. So there you go. That's a workflow in a nutshell. Now, let's say you've done some work and you want to take and back up what you've done to floppy. Well, no problem. Since these are floppy-sized entities, you can basically, and I'll have to remember to bounce out here in order to do this. Let's go ahead. And I will make a new disk here. Pardon me for just a second. It's getting late enough that I'm getting slower. Okay, new disk. New single density disk. Bang. Go back into full screen mode here, so I can keep recording. So let's go ahead, and I can just as easily, I'll make a backup of my system drive. D1 to D8. And as you can see here, considerably faster dealing with the hard drive than it is the floppy. But even so, we're able to back up the work that we've done on the volume and do it very quickly. We'll be done in the next 20 seconds. Boom, done. Okay. So that's that. We'll go ahead and I'm going to save that as my data disk. Just pretend that I'm over here labeling this. Yep. And I've inserted a new disk ready to go. And I've got my source code that I've worked on for the day. And all I would have to do if I wanted to do a restore would be just to do a duplicate disk in the other direction. It works fine. So there we go. There's our duplicate workflow right there. The other thing I want to show you here is that MEDIT allows you to do a lot of wonderful customizations. And this is especially helpful if you need to, for example, excuse me there. If we want to take and do things like change tab stops for a particular file type, assembler, Pascal, C, whatever, or change other editor preferences. And for that we use the MEDIT CM program that we copied over. No really instructions because this should be pretty much self-explanatory. Now, what extension group are we talking about here? And this refers to the three-letter extension at the end of each file. In this case, I'm working with assembler files, for example, ASM. Using the internal defaults, please wait. It takes and does a lot of calculating stuff. Okay, bing, 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 set some stuff up, whatever. And we now have the opportunity to do things like set tab stops, set how long maximum line length can be, which for MEDIT can be up to 200 characters long if you want. Growth factor is especially interesting because it specifies a percentage that you can allow a file to grow so that you don't run out of space on the disk. And that's a fun factor to play with. Right now it's at 100. It's set by default to 100%. You can, of course, also set the default margins so that for the left and the right side of the screen, color of the screen, and a number of miscellaneous flags, which include how to handle how to handle tabs that are displayed, how to store them on disk, how carriage returns are handled, whether auto indentation happens or not, and whether or not to set uppercase or lowercase by default. In our case, I'm just going to set color. And I want assembler files to be shown in a green hue instead of a blue. So for that, we'll just change the color value from 9 to 11, while leaving the luminance values for both the background and the characters the same. So you can see, now you'll notice it said 0 to 14E. By that it means, of course, if you understand how the luminance values on the Atari work, to use even values only. So now we have this green color here. It's ready to go. We save the parameters, return to DOS. And we now have a new file called MEDIT ASM ECF. Now, what they don't tell you is that this file needs to be copied over onto your work disks where your files are being edited. Otherwise, MEDIT will not use them. But it's also a good idea to keep them here on the disk as well, so you can copy them over easily. So we'll go ahead and copy it over. It's now copied over, and you can see it over here. Bam. Okay, ready to go. Now we go ahead and load MEDIT again. And you're going to see something very different here. Now when we load test ASM, there's no pause while it says using defaults. You're basically going to see your text editing session start up immediately. So it's in your best interest to really seriously set defaults. It's a good thing to do. So, there we go. We'll go ahead and change this back. Exit. Now there are a couple of other exit values. For example, exit and edit another file, exit and so on. So exit and reload the file again, that sort of thing. But we just want regular exit. Exit and start. It's saved. Load AMAC again, and let's build it. And back to the seizure-inducing colors. Okay, so now I'll go ahead and just detach the cartridge here so we can see. And finally, on top of all of this, we also have the Amoeba debugger here ready to go for any of our system debugging needs. We'll go ahead and load our test object, and we'll dump it here. And there we go. Our program ready to go, ready to be messed with. New breakpoints. So there we go, just on and on, ready to go. And so on and so on and so on. Everything that you need ready to go right here on your fingertips. Just repeat code, test, debug, repeat, code, test, debug, repeat until you're done. So that's it, really. That's how development would have happened here in a nutshell. The only thing I really didn't show you were things like the ancillary tools, like any graphic editors that might be written in-house. Although to be fair, most coders just use graph paper for that. But you have the meat of an idea of what it takes to take and develop a piece of software ready to go for the Atari, using what would be vintage 1982 equipment with the added luxury benefit of a hard drive. So with that, I hope you guys enjoyed this. I'll be making more of these videos in the future. If you have any questions about any of this, feel free to hit me up on Atari Age about it. Good night, everybody.